Hi, everyone. Thank you for joining. Just give a 30 more seconds for people to join. Okay, yeah, so we can get started. Thank you again for joining. We are excited to host this summit for you, and we are excited that you have joined here. A very, very warm welcome to all of you from around the globe kind of joining the summit, be it customers, partner, consultants, Oracle teams. There will be something for everyone. So thank you all for joining here. So there will be kind of two streams of presentations and discussions here. The one is about the technology update. So the last time we did the summit in 2021, and after that we have released various capabilities in database 21C and 23C. And so we will cover all these technology updates and all the exciting features that we have added here. And then over the last couple of years, we have seen a lot of adoption in various industries around the region. And so we will cover several success stories in the two sessions, session 1 and session 2. So Summit is about kind of bringing the best of minds together, best of people from the industry together. So let's collaborate at this summit, okay? So share your business requirements, use case, your needs, suggest some enhancements, provide us feedback on the features that we are adding. And we love questions, so please do use Q&A to ask questions. There are a lot of panelists, experts, presenters here who would like to collaborate with you, coordinate, kind of answer your questions and so forth, right? And the most important part is that let's continue the discussion after the summit. Our goal is to help you get started with the new with the technology. And we could do a lot of things like technical sessions, workshop, use case validation, POC support, and all. Okay. So today in our session, you can see a list of presenters here. We will have a couple of keynotes, and then we will have technology updates. We have all the product managers here who you can reach out to anytime. And then the customer success stories from Stef and Safaricom, okay? And so we also have session 2, which is evening time here, but will be a different time at your wherever you are connecting from. And there are a lot of other customer success stories here as well. And it's a different customer success stories. So if you could join, please do join session 2 as well. So here's in the agenda for session 1. You can, as I talked about, there are 2 keynotes. We'll talk about the vision and the power of database in memory. We'll talk about all the new capabilities in 23C. We will showcase the data warehouse and data in memory implementation at Stef. And we will also cover the success story at Safaricom. Okay, so that's kind of session 1. And session 2, this is again, like I said, this is in the evening. Please do plan to join. And there are different success stories here. Let me give a brief background here, okay? So organizations like you have many business questions and all. And these business questions are like reports, BI tools, ad hoc questions, dashboard, and all. And the good thing is that, I mean, almost every one of you will have some sort of analytics going on in your company, okay? And this is across the industry, right? But what's happening is that the business at your company, they need fast answers, but they get delayed answers, okay? And this is due to kind of, some sort of analytics delay or the time it takes to get those answers. Okay. Now, the reason for all of this is because the reports are getting delayed. The dashboards and the KPIs are not up to date in real time. The LOB reports are missing those SLAs. The time lags due to complex architectures, the system performance bottleneck and issues, and for any ad hoc sort of queries, you have to re-optimize everything. Okay. And not sure this resonates with your organization, but we have seen this with many of the customers that we have spoken to. And some of these reasons are kind of quickly covered, and I'm sure Tirthankar will cover in his keynote as well, is that the reasons are because many of the shops, they still use the point solutions. They spend most of the time copying and moving and copying the data. There are complex architectures being used and the solution which is not scalable and all. There are also some emerging business opportunities that are coming up, okay? And these are, again, in various industries. And what I'm showing here is just few of the examples, okay? Just like a retailer could provide you some promotion coupon while you are in the store, right? And so there's a lot of just-in-time analytics coming up, okay? So now, given all this background, let me invite Tirthankar to take it to the next level. Tirthankar, could you please start sharing the slide?
Give me 1 second. I'm trying to change my internet. I'm having a lot of internet issues today. I apologize. Hopefully it'll.
So let me briefly introduce Tirthankar while he's bringing up the slides. So Tirthankar Lahiri is a Senior Vice President of Data and In-Memory Technologies Group for Oracle Database.
Hey, sorry, I lost. Give me 1 second. Today, this is called Murphy's Law. When you want things to work, they stop working. So today, for the first time in many weeks, I have internet issues. Let me find my slides. Now, give me 1 second. Can you guys please acknowledge it when you see it? Do you see my presentation? Do you see this now? Can you see my screen? Can you guys see my screen?
Yes, we can. Yeah.
Okay. All right. Let me see. Now put in presentation mode. Okay. Sorry. A lot of drama getting my laptop connected to the correct internet network. Okay. All right. Great. I'm going to keep it short because I really don't have anything very important to say compared to the other speakers. So I'll try to keep this short. My name is Tirthankar Lahiri, and I manage the Data and In-Memory Technologies group in Oracle Database. I see many of my friends have joined, many customers, many partners. So welcome all of you. So I'm going to start with a very quick poll, as an informal poll. Just raise your hands on the Zoom if you can. If any of these technologies that used to dominate the world at one point are still techs that you make use of. So number one, who here uses the typewriter today? Who here uses that? Something that my son has never seen, actually, a rotary phone. Who uses that? Does anyone use that? Actually, how do we do polls here? Should we just do show of hands? 2 participants raised. Okay, well, 2 people have raised their hands. I can't tell for which, but yeah, 4 or 5. A few people have raised their hands. Good. Does anyone use this? Look carefully. It says Windows 95. Does anyone use that? No, no one? Okay, well, I see about 8 or 9 people altogether, which is a small fraction of the audience. So it's a small number of people that use a few of these technologies. I'm guessing the calculator more than anything else. Okay, well, if you look at 5 years out, if you look at database architecture with the way in-memory size is growing, the size of DRAM is growing, what do you think the future of the architecture database will be? Will it be disk-based, where data is basically cached in memory and brought in from disk for processing? Or will it be memory-based, memory-centric, where data essentially lives in memory? It's basically brought in, the memory is big enough that it really never ages out, and processed using in-memory formats. So my claim is that this is what these different architectures represent. On the left, you have the rotary phone. And on the right, you have the smartphone. That this is the way you're going to see database evolve in the future, that basically all processing will be done in memory. When you have terabytes and terabytes of DRAM, your operational data basically fits. And you don't need to go back and forth to storage to run queries or run basic transactions. So this is going to be the future database architecture. One other thing about in-memory that's very important is it is essential for real-time enterprises, which is right now the way the modern world is shaping up. The real-time enterprise is essentially all about speed. It has to be able to use actual data to make decisions. It has to be able to adapt rapidly to change. There's no point using data if it's not able to respond quickly. And it also has to continuously optimize for longer term trends that it observes. So it has to react to day-to-day changes, obviously, but it must make changes based on, observed changes in the pattern of the business climate. And of course, one of the things that make real-time really difficult is slow performance. It's one of the worst things for real-time enterprises. Okay. There's many examples of real-time enterprise. I'm not going to go through this and bore you, and many of you come from many of these companies already, these sectors. But the main theme that's common to all of these, vertical sectors is that they all need to make decisions based on current data. A lot of telecom companies, for instance, will use actual congestion metrics gathered in real time to optimize network placement, antenna orientations, which basically get them the least number of drop calls and the best network utilization. Manufacturing processes have to detect issues right away. They see a change in the tolerance or the observed parameters of products. They have to very quickly adjust their assembly line to make sure they don't release defective products. So in every single industry now on the planet, there is a need for real-time processing. And one other thing that really makes real-time difficult, apart from performance, is complexity. As Ranjan mentioned, the moment you succumb to the desire to have many systems of record, then instantly you basically evolve into a situation that looks like this, that you get to a point where you can't tell what's what anymore. It's difficult to be secure in an environment like this. It's hard to administer, it's hard to diagnose, and it makes it very difficult to be agile and efficient for real-time enterprises. This is an example of a web company that's actually quite successful, but it's only successful because they were able to hire the top PhDs from MIT and Stanford to run this shop. But this site uses no less than 9 different engines. So basically now what you have is many copies of data. We call it copy contagion, where now you no longer know what your data is to run something very basic like analytics. I don't even know how someone takes a backup of the enterprise when you have your data scattered across so many different repositories. Security is a major problem because with security, the way it works is you are as secure as your weakest entity. So if you have many different entities, then you have to keep patching each one independently. It's difficult to be consistent, hard to maintain, and it needs a lot of very skilled engineers. Now, it's not impossible to make this work, but it's a bit like Formula One racing. It's really not for every person. Most of us are just drivers like myself. I mean, I watch Formula One, but I'm not a Formula One, driver myself. So maintaining this is like the Formula One of enterprises. It's where you're much better off in most cases not having an architecture that is as complicated as this, because it's really difficult to keep this evolving and growing and sort of manage it for the future. So I'm going to very quickly walk you through an example that actually is a simple example, but shows very quickly how things become complicated. So imagine we're building an application to place online deliveries, which all of us do now in the post-COVID era. Customers place orders, each store processes orders. There's a delivery service that delivers orders. There's an analyst that checks the metrics constantly to see if they can optimize the business. And the logic includes transactions for orders and delivery, and analytics for both instant decisions as well as longer term optimization. So it's a very simple app premise, nothing complicated here. To make this work, you first start thinking about the transactions you want to support, which is from the customer, store, and delivery service. Very basic operations on that data, nothing complicated, nothing sinister here. Customers, browse items and place orders. Stores process orders and ship the order, restock their products. And the delivery services will schedule deliveries and pick up and deliver the customer. Very simple and basic stuff. So again, for database people, it's very simple to develop like a simple normalized schema with indexes and get all these transaction modules running on that simple database. Very simple. So now you have a single database, a very simple schema, and you get fast transactions with this architecture. No biggie. But again, things like to get slightly more complicated. You then need to add things like real-time analytic queries based on whose answers you'll make certain decisions. For instance, a customer might want to first find out, hey, what's the best phone that I can buy, and then which stores carry it? And if I do buy this phone in this area, then what other accessories do I need? And the store at which the order is placed will have only a few minutes to upsell a few other products to the customer, saying, hey, if you're buying a phone, maybe I can also sell you a calling plan or something else. So that is something that's time critical. You don't have very much time to get the customer's attention. And then the delivery service would also want to know, well, if I have to deliver this order for this customer, then who else can I satisfy simultaneously to optimize my delivery network? So all of these are real-time analytics that need answers right away for the business. And these queries run slowly unless you have analytic indexes. So you have this database that you built for OLTP, but to that you now have to add these analytic indexes that basically give you these responses in real time. So it's still a single database, still simple, but the analytic indexes do add overheads. They slow down transactions because they need index maintenance. They make the database bigger. And more importantly, they only work for the queries you anticipate. So unless you anticipate a certain query and create the index for it, you won't speed that query up. So ad hoc queries might still be problematic. So it requires advanced workload knowledge. Now, when things really get complicated is when you look at slightly longer term analytics. If the business analyst wants to know what the highest margin products are, what the best stores are, what would happen if a discount were offered, like a what if scenario, that is a more complicated question requiring access to lots of data. And historically, queries like these are better off run on a different database altogether, as you all know. So what you end up with is another database to which you basically convert the data into the reporting format through ETL processes, create a different schema on the other side, typically a star schema, and then run the analytics there. And this is what really doubles or more than doubles complexity because it adds a whole new database to manage and to basically run applications on. On that database, again, analysts come in and they look at some metrics very frequently. They want to know what their year-to-date sales are, what the top products are. So these are frequently run queries that happen to basically refresh certain dashboards. And to make these run efficiently, you really need pre-computed summaries or aggregates. You don't want to run these queries over and over again when the dashboards refresh. You want to run against a pre-computed materialized summary of that data. So now you have to now define these pre-computed summaries. So based on the reports you need, the dashboard metrics you need, you'll have to create summaries for quarterly sales, monthly deliveries, top 10 products, and maintain them against that star schema table, the schema that you had set up for this analytic database to begin with. So now you have a much more complex system with a second database and a schema that's different, as well as pre-computed schemas. And what makes this complicated is really, first of all, having a reporting database, which is a new system to manage. It requires logic to maintain it, usually lags the operational database. It has a bunch of extra indexes that also add overheads, which also require advanced workload knowledge. And again, those summary tables I talked about, which are either materialized views or aggregates, they add complexity, they add space and CPU cost, and they usually lag their source tables. So all of these things go into making this very simple problem more complicated. What we really want is to be simple. We don't want people to run on multiple databases unless we're actually getting data from multiple sources to run analytics. In this case, we're not. We shouldn't need predefined indexes or pre-computed aggregates for analytics, and everything should run on the same operational database. The question is it possible? And we wouldn't be having the summit unless the answer were yes. It is possible to make everything run on that operational database. And this is done through what we call database in memory. It's based on a very simple assumption, an observation rather, that the row format, which has been historically used for databases, is ideal for transaction processing because you can access all the data for a given transactions row in one operation. Whereas for column format, whereas for analytic queries, the column format is more ideal because you're looking at all the values potentially in a single column or a few columns. So historically, there's been these two formats for two different workload styles. Database in memory brings them together into one simultaneously active and consistent form, architecture. Transactions automatically use the highly concurrent row format, which supports very high transaction throughputs. And analytics automatically uses the column format, which uses techniques like SIMD vector processing that allow billions of rows per second analytic speeds. And these are both completely consistent formats that are kept simultaneously active. So no matter which side of the fence you are on, you see the same data, analytic queries and transactional operations. The in-memory format is purely in memory. It is not stored on disk. It is maintained quickly as a result because there's no logging or complex operations required to maintain it, to modify it. There are no changes needed for the disk format. So you can add in memory to any database without affecting your on-disk data. And as a result, all the features of Oracle database, rack, security, availability, etc., Golden Gate, they just work transparently, which is a big, big deal. In many systems, when you add in-memory processing or in-memory columnar, it actually changes the architecture, and suddenly a lot of tools don't work anymore with that new analytic engine. This is a built-in engine ground up in the database, so everything in Oracle database automatically works with it. The other beauty of in-memory is that it does not require the whole database to be in memory, although memory has become much more plentiful. You don't want to keep hundreds of terabytes of basically warm data or cold data in memory. You want to keep the hot data. So you can actually subset your data any way you want, and you can also automate that, which Andy will talk about later on, selecting that subset. You can say, I want a certain table or a certain partition in memory, nothing else. And in memory helps hybrid workloads like Megacart, which are transactional and OLTP and analytic workloads. Traditionally, if you have many analytic indexes, index maintenance is expensive, and you only get analytic acceleration for index columns, and they make the database bigger. With in-memory, you can replace the analytic indexes. You can't replace OLTP indexes. You still need those running transactions, things like primary key, unique key indexes you need for transactions. But you can replace the analytic indexes with the in-memory column store. This is not persistent, so updates are fast. You get fast analytics on any columns, and not having analytic indexes makes the database smaller, which is the big plus in many cases. I don't need to tell you about Exadata. I think most of you here know what it is. It's a database machine that combines the ideal database software with optimized storage software. So what we do is we run our own software on both sides, on compute and storage. And this lets us take advantage of a number of aspects of database processing by pushing work down close to the storage tier. That's Exadata in a nutshell. With in-memory, we can push that same in-memory column format into the storage tier, which gives us much, much faster in-memory storage scans. So if I have queries that need to push the scan processing to the storage tier, that scan can now also run at in-memory speed, the same way it does in the in-memory tier, in the compute nodes. So this basically expands the column store manyfold. Instead of terabytes, you now have petabytes of columnar data, because there's a lot more flash capacity on Exadata than there is DRAM capacity. So this means now I can certainly, instead of offloading my longer-term query processing to a different database, I can replace that using this Smart Scan in-memory flash query offload. It's a much more cost-effective and simple way of doing offload compared to running on a separate database. And the beauty of this is that all of the in-memory optimizations work transparently against the in-memory format on flash. There's been a lot of work done in memory in the last several years. We released in memory. It's actually interesting. It's been about 9 years almost. So it's been it's been a while now, but it's been an actively developed feature. Every release, we've added significant capabilities to it. Shashank and others and Andy will talk about some of the details later on. I'm not going to cover them here, but we've done a lot of work in performance and availability and handling multiple types of data, in automating management of the in-memory column store. So a lot of work has been done to make the product a lot easier to use with time, and expect to see big improvements in 23C as well. In-memory, again, is a transformative architecture. I mean, it's good to talk about individual features and capabilities about what it does, but the reality is it is a fundamental change in the way you think about data and data processing. It's like air travel. When it happened, it didn't just make travel faster. You could travel across the Atlantic in hours instead of days. That was a huge change to society. It changed everything. It wasn't just converting like a 5-day ocean voyage to a 10-hour flight, but it impacted the way we do business, the way we do trade, the way governments engage, the way education is handled. All of that changed with air travel. And the same thing is true with in-memory. In-memory is basically something enables instant decision making, which is a huge deal for businesses. Not requiring additional systems means you get much lower costs. You get a better, basically a much simpler architecture, a more agile architecture with fewer moving parts, which is what you need for real-time enterprises. So in the case of Megacart, you can replace, again, analytic indexes with the memory column store. You can replace the reporting database using the in-flash column store. And we have a number of different techniques to do real-time reporting using in-memory, which can be used to replace pre-computed summaries on that reporting database. So all of this enables what we call translytical or augmented transaction processing, which allows a combination of analytics and transactions on all data on a single database. So again, simplicity and speed from in-memory. We've got some good appreciation from the analysts about our capabilities. In 2023, Gartner rated us as #1 for all operational use cases for cloud database. This is in 2023. And augmented transaction processing is what they refer to as a workload category that combines analytics and transaction processing. So a very nice testament from Gartner. Forrester gave us the highest position for what they call translytical data platforms, which again, as you can see, we're way ahead of the others in the pack. Our ability to run transactions and analytics simultaneously, enabled in a big way by in-memory processing, was a key element of this result, key reason for this result. So another nice sort of testament from a very important analyst. I will let you now hear from others, but there's a bunch of other information you can get. So if you would like to take a screenshot of this page, feel free to do that. The in-memory blog has a lot of information and updates on the product. You can get a nice overview of the technology. If you're new to the technology, please look at this technical brief here that describes what the technology does. And of course, you can try Autonomous Database for free, which enables in-memory in the storage tier, so you can benefit from it automatically without even knowing it's there. So it's a great way to just test the waters with the Oracle database. And I think that's it, Ranjan. Do you anything else that I should cover before I?
No, thank you so much, Tirthankar. This was so insightful and a great vision, and the point that you made about that we are continuing on the innovation journey, right? So, and the Gartner and the Forrester reports acknowledges all the technology, advanced technology that we have built. Thank you so much, Tirthankar.
Right, I think I was just on time, right? So
yes.
All right.
So with that, another point, everyone, please ask questions in Q&A. Again, we have several panelists and experts here who could answer your questions. So please do ask questions. With that, let me invite Julian Donchev to share his screen. And let me introduce Julian. Julian, he needs no introduction in the Oracle world, at least. Julian is the global database lead of Accenture and has more than 30 years of database experience. He's the first Oracle certified master in Europe and is also an Oracle ACE director. Julian, please share. Yeah, you can. I can see your screen. So please go ahead.
All right. I hope you can hear me well.
Yes.
Yes. All right. Thank you very much. All right. So I will, in about 20 minutes, I would like to cover some technical topics of why in-memory has so much power in the database world, especially when it relates to Exadata and autonomous, especially ADW. But first, let me introduce myself. Julian Donchev. I work for Accenture. I'm the global database lead of Accenture. I have been for what now 20 years. I've been Oracle certified master. I was the first one in Europe. I'm also an ACE director, and I lead in Accenture not only the global database practice, but I also globally lead our OCI practice. And you can very easily find me on the internet on my blog. I run a blog related mostly to Oracle databases, sometimes even more generic. You can very easily Google for the blog and find it. You saw this picture a while ago, or a very similar version of that. It shows how in-memory developed throughout the years. From 12.1, when it was introduced, until 23C, which is the latest release, now in free developers version, you can see that things moved from in-memory on the Exadata flash. It moved through automation and now into self-management. This is a long journey, which has brought a lot of new features of in-memory to the Oracle database. What I would like to probably cover in the next minute or so is the one that I enjoy most or find most interesting in 23C. It is the automatic in-memory sizing for the autonomous database. Meaning, as DBAs, we don't have to anymore wonder how much memory we should dedicate to the in-memory column store, to the in-memory cache. Oracle can automatically decrease it or increase it. Look at this picture, for instance. It's one version of the system global area of the SGA. In the middle, you have the database buffers, and we have the in-memory cache. Let's forget for a moment for all the other memory components. There is a process called Space Management Coordinator, which works together with the in-memory coordinator and with the database writer to keep a journal of all the transaction entries and all the changes in the in-memory column store. And the in-memory column store is being updated and through the Space Management Coordinator. So you can always disable, if you would like to disable the in-memory column store. There is an underscore parameter called enable space pre-allocation. If you set it to 0, you can disable the process, you can disable the whole thing, but of course you don't want to do that probably. You can enable it with another value called free. You can set the enable space pre-allocation to free. Actually, there are 4 or 5 different values. Let's not go into detail. Basically, the whole thing is that once you use 23C, you now can rely on automatic shrinking or growing on the in-memory column store, depending on how much it is being used. So that makes it also available on autonomous database in ADW. What else we've noticed that will happen in 23C is that sometimes objects are not fully populated. Of course, the object starts to get populated at one point, it gets fully populated, but for those that are partially populated, now the Exadata scan performance is improved more in 23C. And as I said, with the automatic in-memory sizing, we don't need to now manually try to resize the in-memory column store. It also enables applications also to be able to run on autonomous and, of course, taking the advantage of very fast now analytic query performance. How is Exadata related to database in memory? Well, Exadata has a very fast interconnect with special protocols that really speed up the in-memory scale out. Also, you have the high bandwidth, which populates the in-memory column store, which works pretty efficiently, especially even in 19C. And starting from 12.2, ADW uses in-memory feature. I think somebody in the chat asked the question, is in-memory available now in ADW and ATP. So what actually is, and I'll move to the next slide, I'll come back here, is that on Exadata, regardless of if it's on-prem, XSCC or XSCS, it has the full in-memory functionality. While, for example, for autonomous data warehouse, it is possible only on the flash storage side. And I say for now, maybe somebody from Oracle can answer what is the plan to make it available also on the server side. The autonomous data warehouse, it takes advantage, as I said, of the in-memory optimization, but on the flash cache side. Most people use Exadata also as a consolidation platform. So with in-memory, you further enable the consolidation opportunities. You can consolidate more databases on an Exadata if you use database in memory. You need less CPU, you need less memory, you can accommodate more databases. Using Rocky, the Oracle database uses Rocky to duplicate the objects in a real application cluster in the database in-memory column store. You have different servers, and using this is called in-memory compression unit fault tolerance. You can duplicate the objects in the different servers of the real application clusters. It's important to note that database in memory supports Active Data Guard only on Exadata. I guess this is right. I probably need confirmation from Oracle, but I think it's only on Exadata supported for the moment. And the column level decryption and decompression, it reduces really the storage, CPU, and I/O. I covered the last point on this slide where I mentioned that for now, ADW, it's possible to use it, but only on the flash storage side. All right. Very good. In-memory is a good feature. We are all convinced now, but always as a consultant, I come to two very tricky questions. And the first one is that which tables, which partition, even which columns should we place in the in-memory column store? Okay. And question two, how about the values of SGA, PGA in-memory column size? Okay, with the automatic shrinking now in 23C, probably we can answer the last question, that Oracle will automatically take care of the in-memory cache. It will increase it, decrease it whenever needed, so we don't need to do that. But the first question still remains. Okay, you enable the in-memory column store. What tables should I place there? And if you know your application very well, your reports, your SQL statements, your analytical queries, maybe you can directly determine the tables that have to go there. However, if you're a data-centric DBA and you probably manage more than 10, more than 100 databases, and you don't know really how the application works with those databases, there is an easy way. There is an advisor, one of the advisors in the Oracle database called the in-memory advisor. You can download it. There is a My Oracle support note. You can see the number here. You can very easily find it for the search as well. And you can install it. Just, I want to mention that the in-memory advisor doesn't come by default with the installation of the Oracle binaries. And when you create the Oracle database, it doesn't exist. You need to install it separately. It's important to note also that the in-memory option, if it's not yet deployed, it doesn't require the tuning pack license. So for using the advisor, you don't need any licensing. Here is how basically the report would look like. It would give you 3 different sets of objects. First, it will give you the objects that Oracle would recommend to store in the in-memory column store. Here, in this case, I have 116. The second line, the second row, shows that there are 8 objects which are system-owned, so they're not eligible for in-memory placement. We forget about them. And I have 355 objects which would not benefit. But still, I have 116 candidates. So this is a very interesting report, which you can run in SQL Plus, for example. You can run it on any database from 11.203 onwards. So even 11G is supported for running the advisor. And the recommendation, they can be implemented on 12.1 and above. Note that this is only estimates. The advisor does not use the in-memory option. It makes estimates based on the workload. Based on statistics, it eliminates cost of weights, compression, decompression, etc. And it gives two outputs. First, it will give you an HTML report, which will give you recommendations on the size of the column store. It will give you the objects. It will list the objects which should be placed. And also it will tell you the compression type and also what improvement you have from having those objects in the column store, how much time you'll save. That's all. And you have even a SQL script, so you can quickly implement the recommendations. This is a database where I've run the advisor. I have a table called sales. I ran the advisor there. For the SQL script, I got the recommendation that I should place the table sales into the column store. And the command is very simple. It's alter table sales in memory, memcompress for query load. Here is the workload usage. You can see the total database time. You can see the analytical processing time. So if you do not have analytical queries in the database, in the workload that you use and run it upon, Oracle will fail with an error message and will tell you that there is no analytical workload, and that will stop everything. I'll show you soon the error message. Here in this example, bottom right, you can see the analytical processing percentage, 36%. So quite a representative analytical, well, quite and quite, but still I have some analytical processing time. You need to download the zip file. It's called I'm Advisor. And when you install it, it will create three things. It will create the user, I'm Advisor, or if it's a container database, it will be called C I'm Advisor. There is a package called DBMS in-memory advisor, and there is one directory. So it's pretty simple, pretty straightforward. I mentioned here the error message, the top one. If there is no analytical activity, then Oracle will come out with this error message to say there is no analytical database activity, and this will stop there. So you don't benefit much from in-memory if there is no analytical activity. If you have the task, of course, you get the same error message that it exists, or for example, in 19C, the bottom error message, it says that it's not supported to run in the root container. And the two types of output. So look at this one. I have a select statement, a simple select statement, which is considered as analytical statement. Oracle used to run it, found out that it was run for 71 seconds. The saving time was 64 seconds, meaning that when you subtract 71 with 64, you get 7 seconds. The query now runs when the table is in memory for 7 seconds only. 71 divided with 7, it's approximately 10. So that's why Oracle says that 10 times is the estimated performance improvement. It's a good performance improvement, 10 times faster. All right. And then it will give you the second output. It will give you the tables that you need to put in memory. Here, in my case, I have the sales table. It recommends what the compression type you should have for the table. Here, it doesn't recommend memory compressions. It estimates the in-memory site. Actually, it gives you all the necessary information you need in order to proceed and enable the in-memory option. It even gives the script. And this was my last slide. Thank you very much. I do not know if I have any questions because I'm presenting on full screen. Can somebody let me know if I got any questions?
So Julian, yeah, we will. You can take a look at question offline, and then we can answer those questions. Yeah.
All right. Sounds good. All right. That's all for me, Ranjan. So thank you very much for inviting me, and that's all from my side for now.
Yeah. Thank you so much, kind of for sharing your perspective. I mean, you are a visionary leader for the Oracle database, so in the area of Oracle database, so that helps. And what you talked about in-memory advisor, I mean, it's the tool that makes it easy to use database in memory. And you covered most of the aspects of 19C in-memory advisor. And going forward, actually, we are advancing this capability, and Andy is going to talk about some of how we are advancing it and making it more and more easier to use, right? And also, you talked about Exadata and in-memory, how they together bring in the power and performance. So thank you so much for covering all these things.
Thank you very much for inviting me.
Yeah, sure. With that, let me invite Andy Rivenes. He's one of the product managers for database in memory. Andy, take it away.
Hello, everybody. Welcome to the In-Memory Summit. Let me get myself oriented here. I'm going to talk about new features in 23C. I'm a product manager for database and memory, and my email address is there. If you have questions after the presentation, feel free to reach out. You can follow me on Twitter, and then our blog is there with the URL, and I will talk a little bit about that at the end of my presentation as well. So with that, let's talk a little bit about new features in database and memory. So really, we now 23C is almost here. With 23C free is out. And really 23C is the sum of the features in 21C. And for database and memory, we had a lot of features we added in 21C, in addition to the new features we've added in 23C. And so I wanted to talk a little bit about that. Here's a timeline that kind of goes through the different releases that have been part of database and memory. We introduced database and memory in 12.102, and then we've made significant improvements along the journey to now 23C. And so this kind of gives you a picture of all of the enhancements, both from a performance standpoint and from manageability, making database and memory easier to manage. And this is a slide I have that kind of highlights all of the features that we added in 21C. Almost all of these features, I've either blogged about the features or we've done Ask Tom office hours sessions and demos of these features. So if you want to learn more about what we did in 21C, you can go back, and I'll have some URLs at the end to help you navigate to the right places. But there's quite a bit of information about these features and demonstrations. And we're just getting ready to release a new live lab that will have all these features that you can try out there as well. And with that, I want to jump into 23C. So Julian mentioned this a little bit. I was going to dive a little bit into a little bit more detail. This is probably one of the most exciting new features in 23C, I think, for database and memory. We're calling it automatic in-memory sizing, but basically what we're doing is we're having the column store will be able to participate with automatic shared memory management. And so automatic shared memory management has been around for quite a while. It allows the database to manually, or to automatically, I should say, resize the buffer cache, the shared pool, the SGA in-memory areas. And then on top of that, we're adding the ability through AIM, when AIM is set to level high, we introduced automatic in-memory level high in 21C, and I'll talk a little bit about some of the enhancements there, but kind of in conjunction with all this works together to allow us to resize the column store based on workload, whether if it's a very heavy transaction processing workload, the column store may shrink. If it's very analytic style workloads, then the column store may grow larger. You still have to set the in-memory size parameter, and kind of the best practice is to set it basically at your workload working set size, and then from then on let automatic in-memory and automatic in-memory sizing manage the column store so that you don't have to manually figure out where to get the biggest bang for the buck. And I have a kind of a nice video, and I tested this out, but I'm hoping the sound will come back. And please, somebody let me know if you can't hear this.
So far, we can't hear anything, Andy.
No, you can't hear it. Okay, so let me
share computer sound. There is option.
Yeah, let's see if I can figure out where that's at. I had that yesterday, and now let's try that. It's not the same thing, but maybe that'll work. So let me start over again.
Hello, everyone.
Can you
In
hear
this
that
video,
now,
I'll
Ranjan?
show the
Yes.
automatic in-memory sizing. The automatic in-memory will grow and shrink in-memory area based on the user's workload. If it's an analytical workload, the in-memory area will grow. If the workload is OLTP dominant, the in-memory area will shrink and buffer cache will grow. With the benefit of auto in-memory, the in-memory size just needs to be set to a reasonable minimum size. Then it will be adjusted to an optimal size based on the workload to fit the hard disk set. Now let's see a demo of automatic in-memory growth. We started with 8 gig SGA and 2 gig in-memory size. We run TPCH query 1 and see it completes in around 1 minute. If we continue running query 1 for 30 times and see the broker's decision, we notice that the memory broker decides to grow in-memory 5 times from 2 gig to 3 gig. After the in-memory growth, for same query Q1, we can see now it completes in around 16 seconds. We achieved almost a 4x improvement. In conclusion, the automatic in-memory size can automate the size of in-memory column store to automatically manage your analytical workload. Thank you.
Great.
Hello.
So that was that's automatic in-memory sizing, and then as that works with that is enhancements we've made to automatic in-memory. So we enabled, or we brought automatic in-memory, was available starting in 18C, and then we improved in 21C with a new high level. And so that works with automatic in-memory sizing. And we've also added the ability for AIM will now add join groups automatically where they will benefit. In-memory optimized arithmetic can be added. It'll also compress individual columns to a higher compression level based on usage to save space in the column store, but still maintain those columns in the column store. And it can unpopulate unused columns. So kind of the key here is that we've made enhancements to AIM so that you don't have to figure out all of the features that we've added to database and memory and when to use them and when not to use them. We'll do it automatically. So we enhanced AIM to do a better job at keeping track of actual activity. And then it also now keeps track of DML overhead. So there may be cases where for heavy transaction processing, tables won't be populated in the column store until that workload changes on those objects. And of course, the best part is you don't have to change any of your applications to take advantage of that. And this is the third thing. So we talked about automatic in-memory sizing, enhancements to AIM, and then hybrid Exadata scans. So these three features really work together to make managing the column store fully automatic and giving you the biggest bang for the buck. It's really pretty exciting that we're going to do all of this within the database for you, so you don't have to manually do things that we had to do in the past. And so hybrid Exadata scans works along with automatic in-memory sizing and AIM to, so when an object is populated, the AIM is going to try to make the maximum use of the column store. So there will be cases where an object won't be fully populated in the column store. Previously, on Exadata, if the table was less than 80% populated, then we just did a smart scan. On premises and non-Exadata environments, we would still scan the data in the column store, and then we'd go to the row store to pick up the rest of the data. So the query would always run, but it wouldn't run as fast necessarily as it would if it was all fully in the column store. Now, what will happen with hybrid Exadata scans is that if the table is not fully populated in the column store, we'll go run a smart scan on the Exadata Smart Flash Cache for the rest of that data. And so that gives us a significant performance improvement on Exadata running with AIM. And so you don't pay a penalty for not having all of the data populated, because it still winds up being faster to even have partially populated data than not to have data populated at all in the column store for objects that you're doing analytic workload or analytic queries on. And so this is a kind of a three features that all work together to make a big performance improvement in 23C. And then we had a couple questions, and Julian referred to database and memory on autonomous database. We're actually just about ready to release the ability to have the in-memory column store available in autonomous database dedicated. Currently on autonomous database, cell memory is available automatically. You don't have to do anything. but we haven't been able to have the column store available as well. And we're getting ready to make that available. It will use, we'll give you a little checkbox and a slider so that you can change the defaults if you wish in the UI console for the cloud. And then automatic in memory will be enabled at the medium level. So it will be able to actually, once you set objects to be enabled for in memory, then it can manage the and get the most use out of each of the objects that are populated in the column store, and can change that. So you don't have to go around and manage that. So all works together. And that's kind of one of the big benefits of database in memory. It works with all the existing Oracle database features, and we're trying to make it fully automatic and fully automated to help you with your analytic workload. And then we have another feature called selected in-memory columns. This really becomes, I think, more important with the wide tables feature that we added in 23C, where we now support up to 4096 columns. And what we've added is the ability to specify either all columns to be populated in memory, which would be the default, but you can say for tables that are very wide, when you wanted to exclude columns, those commands could become very, very long strings. And so to make it easier, we allow you to say no in memory all, and then just populate the columns that are going to get the most benefit from analytic workload. And so we added the ability to have all. We also have the ability to say that on the in-memory command, so that you could reset your all of your columns without having to unpopulate the table, and then say no in memory to then exclude again. So you kind of get both sides of it, but this makes it much simpler, I think. And one of the things that people have asked about, when you have really only want to have a select number of a small number of columns populated in the column store, but you have very wide tables. So that's in 23C as well. We've enhanced in-memory rack or database in memory with rack level global dictionaries. So this is going to allow us to have join groups distributed across rack nodes. Prior to this, join groups really only worked on a single node. With rack level global dictionaries, we'll be able to have join groups that can work across rack nodes. It gives us a better performance improvement on distributed hash joins. We've improved in-memory vectorized framework, vectorization framework. In 21C, we introduced the in-memory vectorization framework, and it worked on single-level hash joins to further leverage SIMD operations in the join processing for the hash join. And then we've now in 23C, we're supporting multi-level joins, multiple join keys, and then fully supporting grouping and aggregation. So we're making some significant changes in 23C to further take advantage of SIMD vector processing in hash join processing. So this should speed up hash joins significantly and leveraging SIMD operations. And then in-memory columnar JSON. So basically what we've done is we supported JSON since I think 12.2. We support in 21C the JSON data type, and now we're supporting all of the in-memory optimizations for JSON in the Smart Flash Cache and cell memory on Exadata. So we've extended the analytic processing capabilities of in-memory on JSON into cell storage or cell memory. So that now we have you can have a much larger columnar footprint for JSON analytic processing. And so this is another pretty exciting change. We're leveraging our in-memory expressions framework, the same kind of thing we did in 21C with spatial and full text columns. And we're now taking advantage of this for JSON in cell memory on Exadata. And then kind of one of the other big, I think, exciting new features Julian mentioned the in-memory advisor, is that we're now going to release a native in-memory advisor to the database. So it'll be a standalone, or a package as part of Oracle database. It uses heat map, and heat map is now available with no separate license required. So a couple months ago, we eliminated the requirement to have either ACO or database in memory in order to enable heat map. So one of our best practices is just to enable heat map and have it on because it gives you a lot of great information. And now the new in 23C, the new in-memory advisor will be part of Oracle database. So you don't have to download, install a separate package. And we've now added two different tools, an eligibility tool where it can tell you that database in memory would not be useful, and then a comprehensive analysis tool. And we're going to backport that eligibility tool to 19C. And so it should be out in July RU, cross your fingers. But I have a really nice demo that goes through and talks about how this is all going to work. And so let's take a look at that now. And this one should play, so
Hey
everybody should be able to hear
In
it.
this video, we'll introduce version 2
Yes, we
of
can hear.
In-Memory Advisor.
Yep, great. And
a
let me turn
smart
it
tool
up.
designed to simplify your journey towards
It is as loud as
in-memory.
it'll go.
Most of our customers have thousands of databases. Some run analytical workloads, some run transactional workloads, and some a mix of both. The benefit in-memory offers is directly proportional to the amount of analytics in the workload. Databases with predominant amount of analytics become the candidate database for in-memory. We can use AWR reports to infer the amount of analytics in the workload and subsequently to identify candidate databases and to quantify the benefits of in-memory. However, it's time-consuming, prone to errors, and almost impossible when thousands of AWR reports needs to be analyzed manually. We solved this problem with the first version of Advisor. It's a downloadable tool that can analyze AWS snapshots and quantify the benefits of in-memory technology without much manual effort. With version 2, we have built the Advisor natively in the database as a PL/SQL package. No need of any additional installations. We have added more capabilities and enhanced the underlying model. Here's how you can make use of Advisor in 2 simple steps. First is the eligibility test. You can ask the advisor if the current database can benefit from in-memory. It will offer you a yes or no answer along with the amount of analytics it found in the database. Using this, you can easily rule out the databases which do not have sufficient analytical activity in them. To run eligibility test, you have to invoke the PL/SQL API that you see on the left-hand side. Let's see a quick demo. We start off by declaring the 2 output variables, and we invoke the PL/SQL procedure by passing 1 as the input, signifying let's analyze last 1 days of AWR data. Now, this database runs predominantly analytical workload, hence we see true in in-memory eligibility. And in the output summary, we see that it has 92% analytics in it. The second step is the advanced analysis. Of all the databases that made through the eligibility test, you can order them in the descending order of the amount of analytics predicted by eligibility test and prioritize the ones with highest amount of analytics and pass them through the advanced analysis. Advanced analysis will offer you insights on the tables that will benefit from in-memory and also quantify the benefit in terms of reduction in DB time. Let's see a quick demo. Advisor relies on real-time heat map stats for its analysis. We start off by enabling heat map. Then we instruct the advisor to start collecting the required stats by invoking start tracking. After sufficient stats have been collected that can represent the workload, we invoke stop tracking. We then invoke generate advice and instruct the advisor to analyze the collected stats. You can view the predictions by querying DBA in-memory advisor recommendation view. Here are the predictions for a test workload we ran. Without in-memory, the DB time is around 1000 minutes. When you enable in-memory, you have the option to size the in-memory area based on your requirements and memory constraints. As you can see, Advisor shows the different in-memory sizes, predicted reduced DB times, and also the tables that can fit in the in-memory area. With an in-memory area of 1.6 GB, the DB time reduces by 3 times for this workload. In-memory is truly a transformative technology, and Advisor will be by your side in this transition.
Well, there you go. And I think one of the most exciting parts of this is going to be the ability then to not have to install a separate package into, say, hundreds or thousands of databases you might have, because it'll already be there natively. So I think that's really going to be a great benefit. So let's go, oops. So let's go past that. Come on.
Hey everyone.
There we go. So I wanted to end with where you can get more information about database and memory. And so we have guidelines and tools. If you're considering implementing database and memory, want to go through and do a POC, want to take a look at the in-memory advisor, we have lots of information available. We have our Live Labs environment where you can go run Live Labs and experiment with database and memory for yourself on Oracle Cloud. So you don't have to have it, you don't have to download and install it. We've done it all for you. And then we have our blog and our resources page. So blogs.oracle.com/memory, lots of information about database and memory. And then our resources page, where I have a link to our Ask Tom office hours videos and demonstrations, Live Labs environment, videos from on YouTube about the different aspects of database and memory, and of course, lots of tech briefs and links to other documentation. So with that, thank you very much, and I'll turn it back over to you, Ranjan.
Yeah, thank you so much, Andy. As the presentation said, in-memory is truly transformative. So, and also we can see a lot of enhancements and advancements there. So truly transformative technology. So let me kind of briefly give an overview before we go to the next section of use cases and customer stories and all. Okay. Just as we saw, I mean, there are a lot of advancements going into the database in memory. And this is not about just putting the data in memory and done with it, right? I mean, there's a lot more things that goes, how to make JSON analytics faster, text analytics faster, geospatial faster, right? And these has all been built over the years. And then we are continuing the progression there and kind of to add power and performance, scale, intelligent automation with all the things that Andy talked about, auto sizing, auto enabling features, new in-memory advisor and so forth, right? So this is definitely a superior in-memory database in the market. So let me kind of summarize this one. We talked a lot about different advancements and technology, right? And kind of take it a big picture, right? So there is a traditional way of getting performance, and it might require application changes. You might have to move the data to another operational data store or data mart, manage separate compute and so forth. And some of the things that Tirthankar also talked about in his keynote, and manage separate storage, duplicate the data. There is DBA effort required. Then you have to manage security. Again, Tirthankar touched upon that one, manage analytic indexes and so forth, right? And then create materialized views on top of it. So a lot of things, and the people do a lot of heroics to try to get some of these performance benefits. And all of this adds to complexity. It leads to movement of data. Performance becomes, improvement becomes challenging, and it supports limited use case. There is a much more modern and simpler way of getting performance, which is by database in memory. Simply turn it on by changing a parameter. It's analytics on one key value proposition is that it's analytics on live data. We have talked to so many different customers. They struggle to get kind of, analytics running on the live data, okay, and get the performance as well. So that's the key part. And also you get order of magnitude performance improvement, as many speakers touched upon it, and it supports variety of use cases, analytics, and so forth. So in terms of use cases, right, what have we seen across our customer base, right? This is kind of a summary, and you can kind of expand it upon it, right? But what we typically see is, I mean, again, everyone or most organization at this point use some sort of analytics, right? To get some of these business reports. And these are daily, weekly, monthly, quarterly reports. They're very critical reports. It could be LOB, reports and so forth, right? So database in memory helps to accelerate those reports, right? There are, dashboards, KPIs, and all. Everybody wants to keep them refreshed. So again, database in memory, a lot of customers use database in memory to kind of help accelerate the performance of those dashboards and KPIs and keep them live and refreshed. Improve services and faster operations. We will hear next presentation from Binoy about how their company runs the whole business using database in memory. Customer 360, customer retention and growth, and so forth, right? Anything around customer analytics. If you are planning to scale your business, more data, more analytics, that's where database in memory will shine. There are a lot of, again, different new types of analytics coming in, fraud detection, insurance claim processing, and so forth, right? I mean, these are some of these industry-specific analytics as well. Inventory, supply chain management, IT modernization, simplification, all of these use cases where database in memory has been used by customers for their purpose. Another way to look at would be, yes, everybody runs variety of analytics, okay? There are traditional analytics, star schema, and so forth. There is mixed workload analytics where DMLs and queries are going on simultaneously, ERP, fusion analytics, text, geospatial, and so forth, right? And what can help you get kind of unmatched performance for all these different types of analytics, right? I mean, that's where database in memory shines a lot. Another kind of key use case, and this is where Tirthankar also talked about, is the IT modernization and consolidation, okay? You can try to get all this performance by copying the data to another different database, using operational data store, data mart, and so forth, right? But what if you could get all these different types of analytics on one database, and even better if it's an Exadata database, on the Exadata system, where you can kind of consolidate all your workloads, and using in-memory, you can get superior performance and faster analytics, right? So that would help. And if you're also using, let's say, Oracle database on third-party cloud, right? And they're also, I mean, there are usually performance challenges and other things. You could enable database in memory to get faster performance for those workloads as well. This is kind of shows performance benefits that has been seen by many of these in-memory customers. And these some of these reports are quite public. You could access it on our homepage. And you can see here many of these customers, whether they use the commodity hardware or Exadata, they have seen up to 100x performance benefits for queries, for workloads, and so forth, right? So again, please do try it out and let us know how we can help in the process. These are, again, publicly available customer stories and logos that I've added here, and do get in touch with us. We can share some of you. Many of these things are already online, so yeah, we can share with you. One other kind of key thing, and we can talk about in another session, is database in memory can be used for, SAP sort of applications as well. And this has been used for many years, kind of database in memory for SAP sort of analytics. And one key workload that we have found in SAP BW that is kind of no-brainer. Okay, we have seen it being successfully used in several customer shops. And yeah, if you are running SAP sort of analytics, let us know how we can work with you, and we can help you in the process to make your SAP workloads run faster.
Hey, Ranjan, you got some weird flashing on your screen going on. Is that intentional? Yes, it's flipping.
Okay, anyway, I'm stopping the share. So yeah. So with that, let me invite our customer, Binoy Kola. Binoy, could you please start sharing your slide?
Yeah.
Okay, so Binoy is a BI and EPM manager at Stef, and over last 20 plus years, he has been working for several French companies, and he's in charge of building a performant BI and EPM environment. Binoy, take it away.
Thank you, Ranjan. Can you see my screen without the taskbar? Or
Yes, we can.
Okay. So hello, everyone. Thank you for the invitation, Rajan. It's a great opportunity for us to share what we have done with Oracle in-memory database. So I'm Benoît Collat. I'm head of data at Stef. So head of data is data engineering, data science, and business intelligence. And my presentation is how we implement Oracle in-memory database for our data warehouse. Before jumping to the EMDB aspect, let me say some word about Stef. Stef is a European leader for temperature-sensitive logistics. Our expertise and our coverage, regional coverage, enable us to provide a solution for food industry, supermarket chain, and food away from home operator in 15 European countries. Stef is a more than 4 billion euro company with 22,000 employees around Europe on more than 250 logistic platforms. The business of Stef is to handle the customer logistic challenges, from collecting the food at the production site, which can be frozen industry or chilled industry, through providing logistic operation like warehousing or order preparation and conditioning, but also supply chain optimization, property management, or IT and digital solution to the delivery of the food to logistic platform or in the different sales outlet. And to run our business, manager at any level, which can be business unit level or even on the logistics site, need daily and detailed information. And the mission of the data team is to deliver centralized full BI self-service. And our goal is to deliver to all our users. We have today more than 3,000 users, detailed data they need to support their decision process or analyze in detail the information they need. So what we have tried to do is to limit the data aggregation and to limit also business rule we apply on data, and leave our user do the aggregation or apply business rules on the data based on what they would like to analyze. And this is possible thanks to in-memory database and the performance we have with this technology. Our BI environment so is about to collect data from every ERP or application we deploy in the group. We are collecting data from SAP and the different functional modules that have been implemented. So finance for account receivable or account payable, human resources, purchase to pay process, and also maintenance aspect. We collect also information from Salesforce for sales management and customer service. And for all our operation, we are collecting data from time tracking application, time of employee on the platform, but also the driver, the time related to driving. And the largest part of the data we are collecting came from in-house build ERP for warehouse management and transport management. all this data is stored in a single Oracle database, which is the main part of our BI environment. And the data volume on disk represent 46 terabytes of data in our data warehouse. To be able to give access to our user in a self-service way, we work a lot on the model of the data we expose through our end user tool. And we are using star schema for every data mart that user can access. And for example, I mentioned the largest fact tables we have in our data warehouse. For transportation activity, our fact tables is 4 billion lines. For all the dock activity related to transport, we have a fact table of 780 million lines. For billing fact tables, we have 2 billion lines, and for warehouse activity, we have more than 4 billion lines. All the model, the star schema model, are implemented with a constraint between fact and dimension tables in a real, relay, and no validate mode. The relationship validity is managed by the ETL and not by the database itself. And one important thing that we put in place and that was mentioned is the capability to select what data you are putting in memory and what data you are not putting in memory. And we implemented a partition on our largest table. One is called warm for the one with the data we are putting in memory, and we have a cold partition for the data only remaining on disk. It's important to mention that you can query without taking care of what data are in memory and not in a single table, and the database engine deal with this different storage area without having any problem on the user point of view. So all the data are processed through an ETL tool. We are using Pantao Data Integration as our ETL. And all the data coming from the different sources I mentioned are processed to by more than 200 processes that are streamlined through one automation. And the data are delivered to our user through three main solutions. We are using IBM Cognos Analytics for reporting and self-service. We are using Pantao Business Analytics for dashboarding, and we are using Oracle Hyperion Planning for forecasting and budgeting. But more than this BI environment, for the last year, we are using the data we stored in our data warehouse for other purpose. And thanks to the performance we have to access to the data, we are able to deliver the information on mobile, and we build our own mobile application to deliver indicators to users. And we are providing also the data through API, and we implement OData API gateway to provide the data of the data warehouse to other usage. And we have two main new usage of the data coming from our data warehouse, which are digital mobile application and also conversational BI. And this can be done thanks to the performance of in-memory database. So we started using Oracle in-memory database in April 2019, and we go live on the 18C version. In 2020, we have a major project on the transportation activity analysis, and we did it in 6 months. And recently, so now we are upgrading to 19C, and the version we have in production now is 1917. And this April, we upgraded our server. And the next slide is about the characteristics, of our server. The server has 4 CPU, each CPU having 10 cores, and our server has 6 terabytes of memory. And I mentioned also the setup of the different area of our database. So SGA is just more than 5 terabytes. And you have the different sizing of this area. Notice that we created a RAM file system to support sorting operation and to have good performance on sorting operation. And last thing I can say is that on the more than 40 terabytes of data we have in our data warehouse, 11 terabytes are exposed in memory, in this 6 terabytes of memory. So as a conclusion, what we could say is that for a business user, as it was said, adopting Oracle in-memory technology is really a game changer. You have such performance to access the data that it reduces our decision process, and the time between data creation and data access by the user. Sorry. Also, for us, it's a way of boosting our innovation. As I mentioned, we are now able to provide mobile application or conversational BI, which need performance because users are not waiting when they are in such interaction with application. For a data engineer, in memory is really the easiest way to manage data. Data volumetry and processing issues are really postponed to the next level. But what is really important for us is that data model remain important to get all the benefits from in-memory. And for a data administrator, it's a skill upgrade. In fact, everything remains the same. It's an Oracle database, but with a new module that allow not to have indexes to do analytics, and that reduce a lot the administration aspect. So that's all for me. And Jan.
Yeah, Thank you so much, Binoy. And again, this is one of the best implementation of in-memory that Binoy and team has done. Binoy, could you talk about a little bit about what were the business challenges before this implementation and how this has transformed?
The main issue we have was that we were not able to deliver daily data to our business analyst, especially on the operation information. And thanks to the performance we have with the database, we are now able to deliver any source of data the day after. And we are also able to build enhanced analytics calculation. I mean, we are providing carbon footprint calculation and daily profitability on our transport activity, which is really important and enhance the value we brought to business.
Right. Yeah. Thank you so much, Binoy, for this added insight. And thank you for your presentation.
It was a pleasure. Thanks.
Yeah. With that, we have saved the best for the last. We have next speaker, Stanley Muthia from Safaricom, who will talk about database in-memory implementation at Safaricom. And Stanley is the data administration planning lead. He will be supported by Tuli Masayuki, who is also database administration operation lead, and Dennis Kipruto, who is the core IT infrastructure lead. Stanley, take it away. Can you please share your slide?
Thank you very much. Rajan, let me share.
Yeah.
Thank you.
I think at this point, at some point, it will be very interesting to hear your story, how you had a kind of a big business challenge, and how database in memory was able to solve that business challenge, and it also brought your CEO and CIO to the notice or the impact that database in memory brought, right? So we would definitely like to hear that story as well. Go ahead, please continue sharing. Stanley, we can't see your slide.
Just a minute. Just a minute.
Yeah.
Just a minute. Share again. Share and then I stopped.
Okay, now we can see your slide. You can put in the slideshow mode. Could you put it in the slideshow mode?
Okay.
No, slideshow mode. Yeah. Actually, it made it smaller. Okay, go ahead. Yeah.
Let me.
That's correct. Yeah, perfect.
This is okay?
Yes. Go ahead, you can get started.
Just a minute. So, hello everyone. So this is my presentation. We have called it subscriber registration, the rush to compliance. So I'll move on to the next slide, just to do a brief introduction. So I'm Stanley Muthia, just as it has been indicated. I'm the database administration planning lead within Safaricom. So Safaricom is the leading telecommunications provider in Kenya with about 64% market share. And it's globally known as the home of M-Pesa, a mobile banking SMS-based service. So currently we are also in Ethiopia. That's our latest acquisition. And we offer mobile telephony, mobile money, consumer electronics, e-commerce, cloud computing, data, and all that, streaming, fiber optics. So Safaricom is a company that has a purpose of transforming lives, and it is also led by a vision to be a purpose-led technology company by the year 2025. So if you look at the slide here, as a purpose-driven company, we have the connectivity, financial inclusion through M-Pesa, and then our contributions towards the planet, economic empowerment of the youth and the less privileged in the society, health and education. So in the year 2022, that is last year, the government, out of increased complaints of fraud and widespread threats from terrorism, drug trafficking, money laundering, extortion, and all that, gave a directive that all the mobile telephone providers within the region or within the country have to register their subscribers all over again with all the details, including a physical copy of the ID, which was to be scanned and stored as a document within the DB, within the database. So in that, it meant that we had to re-register afresh all our subscribers in order to safeguard the public and follow the government directive. So here I have a public announcement that had gone out for the customers to notify them that in accordance to that government directive, they were expected to re-register their SIM cards once again, afresh. So the deadline was on October 20th. That was the deadline that the government had given, which subscribers needed to have registered their lines. So in Safaricom, the data for subscribers is stored in an Oracle database known as subscriber registration database. And the database runs off Exadata hardware, X8M, and the database is in 19C. So our high-level architecture of how the subscriber registration looks like with the process flow here. We have the subscriber, this one that we are calling SubReg portal, where now it interfaces with the users or the customers. They were supposed to register. There are also USSD services and all that. And then it's a 3-tier system with the middle layer here for API calls that are made to the SubReg or subscriber registration DB to get and also to fetch records. So it gets records and it fetches records. So the records will be returned to the portal, and also the customers who are being registered either from the shops, portals, USSD services, and all that. The data is also fed into the DB again through the same layer. So this here is a photo that shows how it was looking like ahead of the deadline. So we had long queues outside the shops, and it was a crisis all over because for those customers who hadn't met their deadline, their lines were to be disconnected from the network. So everyone was rushing to make sure that their line is not disconnected. Now, during the presentations, the initial technical presentations, the first presentation, they talked about slow performance being the biggest enemy, and ad hoc queries in the database can really cause that. So this is the case that we're faced with. So due to increased traffic in the database as a result of this rush, we had a serious surge in traffic, which created a lot of bottlenecks across all the channels that were being used in the SIM registration. That is the web, the mobile, and the USSD. So at the same time, when we talk of these ad hoc queries, the business wanted to know and the management wanted to know how we were doing in terms of registrations. So there was also real-time reporting that was being required on the status. Then on top of that, there was a requirement for users who wanted to know if their details were okay. So they were also sending, there was also a USSD service that was being used where users could dial and check on the status and know if they required to register again or their registration details had been captured well. So when you look at all this, it meant that our database moved from a simple OLTP DB to a mixed load DB with a requirement for ad hoc queries, which now brought in the whole aspect of OLAP and everything. And this was not the best time for all this because there was high density required in terms of response time, especially for USSD service, which will always time out within seconds. It will not give you a lot of time to be able to wait on the queue to write into the database or read from the database. So the DBA team, of course, we were very much involved, supporting the application team to try and unlock the bottlenecks that were being faced. And we did a lot of tuning to try and improve the customer experience and also to try and ease the pain that was going on in the shops. So at this time, it's not possible again to transform our enterprise architecture. So it means that it's the database that needs to conform and give the required output. So after some careful deliberation and analysis, together with our SES engineer who was on site, we decided to try out and implement the database in memory by moving the table that was frequently accessed to in memory. So, that is what we did. Fortunately or unfortunately, I have also learned a lot in this session for today. And one of the key take homes or one of the key things that I've learned that has really that I'm really keen to try out is the automatic sizing for in memory, the advisor. So unfortunately at that time, we didn't know of that and we didn't know of how to use it. So we just used what AWR was giving us and ADDM, and we definitely knew the frequently accessed tables. So there were two tables, the subscriber registrations that holds our subscriber data, and then there was another table for reference lines. So we moved the tables to in-memory. The DB, the SGA was 100 GB in size, and we allocated an in-memory size of about 32 GB. So instantly after that, there was improvement in terms of performance of 100%. And immediately we started receiving 99.9% success rate in terms of registrations, in terms of the people who are running the ad hoc queries to do reporting on the status and everything. So there was improvement. Basically, we placed it at about 120%, and all the weights in the database that we could see from the OEM and other performance tuning tools cleared. So all the channels that were feeding from the DB experienced great improvement. So database, and since we implemented that, the database has been stable, and we have not had any challenges as far as in-memory is concerned, or even database performance is concerned. And then, of course, we were able to register, to re-register. That is because it was a fresh exercise all over again to register 98%, which translated to about 41.3 million of our customers. So we were also able to meet the regulatory deadline. Remember, when we were doing this, it was towards the end, and the customers were happy, the organization was happy, and as Ranjan has specified, I had mentioned to them that everyone was amazed by the quick turnaround of events, and our CIO had even to send a message to the CEO to let him know that an action has been taken at the database layer, and a feature that was not being used before has been activated. So the team has activated a feature that has enabled them to achieve that kind of performance and that kind of excellence in terms of the work that was going on. So the products that were being used, of course, I mentioned when I started, is the Oracle Database 19c. It's on rack within the Exadata platform, 2-node rack. It's on Exadata X8M, and of course the monitored and Oracle database in memory that we enabled on that day, and OEM for monitoring. So that is my use case, very, very brief. And for us, we can say in-memory came to save the day, and it did magic for us. Thank you very much.
Yeah, thank you so much, Stanley, for sharing. And this is what, from the product side, we would love to hear is that some of the product and things that we work on can provide so much of an impact, right? And just like you said, hey, a feature that was not being used and can certainly provide so much of an impact. So, I mean, this is what I wanted everybody in the audience to kind of also hear, how they can use in-memory to kind of get an impact to their business. Yeah, thank you so much, Stanley.
Thank you.
Yeah, so let me, can you stop sharing, please? Okay, so I think as you have heard in kind of the two presentations, I'm sure that should have been motivating to kind of start the journey. So this is my call to action, okay? And again, as everybody knows that, I mean, the data and analytics and both are kind of increasing. Everybody is using more and more data, more and more analytics. And the best time to use database in memory is now, okay? And just like we talked about, it can help or provide business impact in various ways, not only performance, but IT simplification and modernization as well, by enabling real-time analytics and plus kind of savings from simplification and consolidation. Again, my point would be, hey, let's collaborate. We are here to help you. We are here to kind of help you get started. Provide us feedback, share your business requirements, use case, suggest enhancements to us. We are eager to work with you, and kind of let's continue the discussion after the summit. And I mean, we can do a lot more things. We can organize one-on-one sessions. workshop, use cases, validation, POC support. Again, we are in the journey with you. So, I mean, together, let's start build solution for the future and start the journey today. And we are together in the journey with you. Tirthankar, you're there?
Yes, I'm here. I was looking for the unmute button. Sorry. Yes,
Yeah.
I'm here.
Any last minute thoughts for the audience?
No, I think it's been fantastic hearing from the customers, hearing from the partners. Julian, Benoit, all the talks are very, very good. So I think it's we do a lot of engineering work, as a lot of you know. It's really, really gratifying to see the stuff being used in practice, solving real world problems. So honestly, nothing makes us happier than to see these use cases in action. So thank you for taking the time and handling all the time zone differences. I have no idea how many time zones this audience spans right now. Probably several, I'm guessing.
Yeah, it's around the globe. And yeah, I'm sure people are joining from all over the place.
Yeah, it's late afternoon, late evening. So thank you very much, all of you. And the talks were very, very inspirational, I think.
So just to kind of reminder, we do have a session 2, and we will have different customer success stories that you can hear from various customers from India, China, and other places. So please do join in session 2. Again, this is the agenda for session 2. So if it is possible, please do join. Again, it will help you in the motivation to get started.
Hey, one quick thing I wanted to mention. I saw a couple of questions on this. So people said, if we have questions, whom do we ask?
Yeah, so I did provide my email ID, and
I think we should provide all of yours. So you,
yes.
and Andy and Marcus.
Sure. I mean, the point is that, at least one connectivity. Yeah. So and people can just send an email, and we work as a team, so we'll kind of respond, definitely respond. So just let us know any question. And of course, if you have any last minute question, please also kind of let us know. We can answer in the next 7-8 minutes. We can answer your questions.
Ranjan, I've already provided mine and yours, definitely. So we just do Marcus and.
Yeah. Let me stop the recording.